my friends. So, we are moving on from just basic graphs and writing equations from graphs, and we're actually going to talk about why we're doing this because there are so many real world applications of trig functions. And usually, I actually make my kids like list off a bunch of things in nature that are periodic because we see this stuff all the time. I mean, something as simple as seasons of the year, like winter, spring, summer, fall, winter, spring, summer, fall. And you can kind of talk about how there's high temperatures, low temperatures, things like that. And they all follow some sort of a periodic pattern, which is really cool. So this stuff like shows up in real life all the time. So I have a couple examples for us to do today. And you have a note sheet. It all goes along with the note sheet. And the first one is a Ferris wheel. So I'm actually starting a new sheet right here just because I would draw this on a separate part of the board anyway. And you can write this down or you could just watch this part. So let's pretend this is a Ferris wheel. We're at the Jersey Shore. We're at the boardwalk and we're going to ride the Ferris wheel. Okay? And when I'm talking about the Ferris wheel, I'm going to talk about my altitude at the time that I'm riding the Ferris wheel. So I actually didn't even read that first problem, so I have no idea where the ride is starting. But let's just say everyone gets loaded into the Ferris wheel and I start riding in this position. And the Ferris wheel is turning clockwise. So I'm going down, right? So my altitude at this point, I'm just going to make it right here. Okay? So let's just say I have a graph. And this is not important right now. So let's just say my altitude is right about here. And then all of a sudden I start traveling in a circle, right? And I do this over and over and over again. So at some point, I'm at the bottom of the Ferris wheel. And then my altitude, as I travel back to the top, eventually I'm at the same exact height I was when I started, even though I'm at a different spot on the wheel. And then eventually I'm going to be at the highest point. And then after that, I'm going to get back to where I started. And if you guys can look, the altitude as I ride this Ferris wheel looks very much like some sort of a periodic function, okay? Now, I don't have any specifics on here. I actually hate the way that looks, okay? But you can see that my altitude as I ride this Ferris wheel follows some sort of a sine or cosine graph. Oh my gosh, this is so cool. Let's go back and read that problem. Okay. As you ride the Ferris wheel, your distance from the ground, I really don't like distance, or altitude from the ground, varies sinusoidally with time. So let's talk about this word, sinusoidally. You guys see this and you think it has to be a sine curve. That does not mean it has to be sine. It can be sine or cosine. It just means that it's following some sort of periodic pattern. You are the last seat filled and the Ferris wheel starts immediately traveling counterclockwise. Okay, so that means that this Ferris wheel, I was the last one on and it started traveling counterclockwise. All right, so a little bit different than the scenario I had just described. So this is more of I started at the bottom, and then eventually I got to the middle, and then I got to the top, and then I went back down to the middle, and back down to the bottom. So this is more like looking like a negative cosine to me, but that's just, I read a sentence. That's all I did. I read a sentence. Let's see what else happens here. You were the last seat filled, and the Ferris wheel starts immediately, blah, blah, blah. Okay, let t equal the number of seconds that have elapsed since the Ferris wheel started. You find that it takes you 15 seconds to reach the top, which is 43 feet above the ground, and the diameter of the wheel is 40 feet. Okay, so I can start labeling some things here. So the highest, excuse me, the highest point off the ground is 43 feet, and it took me 15 seconds to get there. So remember, time is always your x. So at 15 seconds, I was 43 feet off the ground, and it says the diameter of the wheel is 40 feet. So when I started, t was 0, and I was, 3 feet off the ground. Why was I 3 feet off the ground? Because there's some sort of platform here. And if the diameter is 40, 43 minus 40, well, this is 3 feet off the ground. Interesting, okay. So I've got 2 points on my curve, and that's all it gave me. So it says sketch a graph. So I'm missing some things in here that'll help me sketch the graph. So let's see what I do have. All right. So I do know my highest point is 43, and I know the lowest I went is 3 feet. I could try to find this point right here. If it took me 15 seconds to get to the top, that means it's going to take me 7.5 seconds to get to this point right here, because I'm halfway to the top. So another thing we could think about is, well, if the diameter of this Ferris wheel is 40, then the radius is 20. So that means that there's 20 feet above and 20 feet below the axle, right? This would be the axle of the axis, of the Ferris wheel. So if I was 3 feet when I started and then I traveled a radius in height, well then this height right here, this altitude, is 23 feet. And then I would travel another 20 to get to the 43. All right, so I just found my midline is 23. So I'll put that on here. And now I just kind of have to figure out my x-axis, which is just time. So I start at 0, and then I get to 7.5, and then I get to 15. Well, it's pretty clear that my interval is 7.5. And I have some sort of a sketch on here, or some sort of a scale that I can kind of go with right now. So when I started, I was at an altitude of 3 feet. And I traveled, and just like we kind of guessed, this is a negative cosine curve. And it doesn't say I have to sketch for 2 periods. I'm just trying to get an idea of what my altitude looks like when I ride this Ferris wheel. All right, so I have my graph. That's part A. What is the lowest you go as the Ferris wheel turns, and why is this number greater than 0? So we've already determined I'm 3 feet off the ground at my lowest point. So why is this greater than 0? Well, think about it, guys. We can't have a Ferris wheel scraping the ground every single time it goes around. The Ferris wheel would break. Okay, and that's why Ferris wheels have platforms, so that they're not scraping the ground, and there's like a little hole there when your feet are there. So every Ferris wheel, for the most part, is going to have some sort of a platform, and that's why this number is greater than 0. You're never, unless we have a Ferris wheel that goes underground. Now that would be a fun problem. Maybe I'll write one of those. But for the most part, this is always going to be positive. So write an equation that represents your ride. Well, we could do a sine equation. We could do a cosine equation. We've been doing this for almost a week now, writing the equation from the graph. I can totally do this. I have the graph. I can write the equation. I know my midline is 23. My amplitude, and I can see, so from 23, I go up to 43, or I go down to 3. So my amplitude is 20. So I'll give you guys a hint. When you guys are doing a Ferris wheel problem, your amplitude is always your radius. So if the radius is 20, that's your amplitude, because that's what you're traveling up by from the middle to the top, or from the bottom to the middle. You're traveling the radius, or the distance, that's your radius. The period, now that one took me some time to figure out because I had to realize what my interval was. So my interval is the amount of time it took me to get from the bottom to the middle, and then from the middle to the top. That's your interval, the time it takes to get to each of those key points. So if I know that my interval is 7.5, the time it takes to complete a full wave is 4 times the interval, which in this case is 30. So my period is 30 seconds. So 2 pi over 30 is my B value, right? So B is pi over 15. All right. So I think I can write an equation now, because I'm not going to put a horizontal shift in there. Why would I? That would just be so silly of me. I'm going to write a negative cosine, right? Negative cosine does not have a shift. So I have y equals 23 minus 20 cosine pi over 15 x, right? That's so cool. Find your height above the ground when, so these are easy times. So eventually I'm going to give you a little bit more difficult ones where you might have to use your graphing calculator. But for right now, these ones lined up right with our intervals. So find your height above the ground when t equals 7.5. So at 7.5 seconds, my height, or my altitude, was 23 feet. 60 seconds. I didn't go out that far. But can we use common sense to figure out where I would be at 60 seconds? Absolutely. Where would I be? At 60 seconds, I can see that we have a little mistake on our answer key right here, but I'll fix that. At 60 seconds, that's another period. So I would be at 3 feet off the ground. And then at 75 seconds, well, I could do, so that's another wave, would take me to 60 seconds, right? And then 75 seconds, so that's 15 more seconds. So it's 75 seconds, I would be up at 43 feet. Okay. What is the value of t the second time you are 23 feet above the ground? So this is the first time I'm 23 feet above the ground. The second time is when I go up and I start coming back down again. So the second time I'm 23 feet above the ground, that happens at 22.5 seconds. That's a Ferris wheel problem, guys. If you need to go back and listen to that again, you can, because I probably went a little quickly there. We're going to do a ton of these. And you're going to fall into a routine. So, like, you'll realize the midline is always the platform plus your radius, right? The platform here was 3 feet, and then my radius was 20. So 23 feet was my midline. So that's one application of trig functions in the real world. Let me do a couple more with you. Oh no, maybe I didn't even screenshot these guys yet. So let me come back to my Word document and screenshot to get the next problem up. Okay. Oh, we've got an alien. So this is kind of a silly application because, well, I mean, maybe aliens do exist. I don't know. But it's still fun. Researchers find a creature from an alien planet. Its body temperature varies sinusoidally with time. 35 minutes after they start timing. Where am I here? Okay. It reaches a high of 120 degrees Fahrenheit, and then 20 minutes after that, it reaches its next low at 104. So because it says it varies sinusoidally, I know I have some sort of a periodic shape going. Right? So it says sketch a graph, write an equation, and then it's asking us about some temperatures. Let's figure out what's going on here. So I need to draw myself a picture. So I'm not going to draw a Ferris wheel because this is not a Ferris wheel problem. But I am going to give myself some sort of a sketch before I actually move this onto a coordinate plane. So 35 minutes after they start timing, I'm at a high. Okay, so that's an ordered pair. So 35 minutes after they start timing, I'm at a high of 120 degrees Fahrenheit. 20 minutes after that, I'm at a low. Okay, so 20 minutes after that, please don't put 20. 20 minutes after that is 55. I'm at a low of 104 degrees Fahrenheit. All right, so I'm just going to go with that. Let's just say it looks something like this, right? If it varies sinusoidally in time, I could go backwards, I could go forward. But all I need, if I have a high and a low, all I need are 2 points, right? And I can find the middles, can I? 100%. So 35 and 55, the middle of that is very clearly 45 seconds, or minutes, not seconds. And then if I want to find the middle of 120 and 104, that's 112, right? I go up 8, I'm at 112. I go up 8 again, I'm at 120. And you guys can just find the average by adding up and dividing by 2. So guys, I look here. This is very easy to get more points. All I had to do was the average of 35 and 55 and the average of 120 and 104. So here at 75 minutes, I would be at 120 again. But again, I don't really care about going out that far. That's over an hour. But let's sketch a graph and kind of figure out what this looks like. So I'm going to do 5, 15, so my interval is obviously 10. And I just so the graph isn't that specific. Usually it's going to say sketch a graph that represents the alien's temperature since you started timing. So I'm just going to kind of get all these points on here. 35, 45, and this is kind of what we already know. The 55, the 65, and the 75. My key points up here are 120, 112, and 104. Okay, so I'm going to put the points on that I know. So at 35 minutes, I was at a high of 120. The alien was at a high of 120 degrees Fahrenheit. And at 55 minutes, the temperature was a low. And from that information, we gathered some extra points on the side in our scratch work. So I'm going to put those up as well. I actually like to draw in my midline too. Okay, that midline doesn't look too great, but we're just going to go with it. All right, so I'm going to work backwards and get some more points and kind of get an idea where I was. And then -5 would be 5 minutes before I started timing. I'd kind of be up there. So my y-intercept is somewhere in between 112 and 120, but I don't care too much about that just yet. So here's my graph, and that graph would give me full credit. It doesn't say it has to be 2 periods. It just says sketch a graph. So as long as I show all my information on here, very clear that I know what I'm talking about. So now it says write an equation expressing the temperature in terms of minutes since they started timing. Okay, so since they started timing means we're basing this off of t = 0. So t = 0 is right here. And I don't have, if I was going to kind of sketch this in here, I don't have a y-intercept that falls directly on one of my intervals, right? It's not at 120, it's not at 112, it's not at 104. That's okay. I'm just going to have a horizontal shift in my equation. So you can kind of choose to do whatever you would like. I'll just start with the one that they gave me. I'll give myself 35, okay? So this is the point I'm going to base everything off of since that's what was given to me in the problem. Could I just do a negative sine curve starting at 5 seconds? Absolutely. Anything you give me that's correct is going to give you full credit. So I know that my midline is 112. I know my amplitude is 8, right? The period, so 2 pi over the period is equal to b. So my period, let's figure that out. So if I go from a high to a high, that took me how many seconds? From 35 to 75, that took me 40 seconds. 40 minutes, sorry, I was still thinking the Ferris wheel was in seconds. So this is 40 minutes. So pi over 20 is my b value, okay. And then I just know that there's a horizontal shift in there. And I'll write this as many ways as we want. They're all going to give me credit. So I get y equals 112. I'm going to do a positive cosine. Plus, my amplitude is 8. 8 cosine, pi over 20, and then parentheses, x minus 35. That gives me credit. I could have done a negative sine, so I could have done 112 minus 8 sine, pi over 20, and then if I was doing a negative sine, I would have chosen this point right here, x minus 5. You'll get credit for whatever you give me as long as it's correct. I don't care. All right, so I sketched a graph. I wrote an equation based off of t = 0, so based off of when they started timing. So now we have the tricky question. What was the temperature when they first started timing? So that's at t = 0. But I have a problem. In this other one, I asked you stuff that was very easy to read off of your graph, right? Any of the points, or what was the height when t = 7.5? Well, that was one of your key points here. All of a sudden on this one, I'm asking you what is the height, or what is the temperature when we first started timing? Well, the only thing I know is that it's in between 112 and 120. So what we need is to find out the exact temperature. And the only way I can do that is if I have a calculator, okay? I have an equation here, right? And if I take this equation and I plug in 0, right, for x, when x is 0, this could be t or x, so when x is 0, I would then know my temperature when I first started timing. So I'm just going to erase a little bit over here so I have some space. So you guys can do this in your calculator. Just make sure that you're in radian mode because we are working in radians right now. So hit the mode button and make sure you're in radians, and let's figure this out. So I want to know when x is 0, what is my temperature? So that's going to be 112 plus 8 cosine, pi over 20, and then 0, so times negative 35. So just make sure that you're taking the cosine of this whole value here. Okay, so I always simplify it one step further. So it's 8 cosine, and that would be the cosine of negative 35 pi over 20. So there's no need to simplify that. I know they're both divisible by 5. When you type that into your calculator, the calculator will just simplify that for you. And if you type that in just like that, as long as you're in radian mode, you're going to get an answer of 117.66 degrees Fahrenheit. And that matches up very well with what we kind of thought over here. I know my graph isn't completely accurate, but I also just want to show you one other thing that you could do. Let me bring this up. So I already graphed this on Desmos, and you could do it on your graphing calculator. Just make sure you're in radian mode. And I obviously adjusted my window and everything, but something that you can do, and I'll show you this more in class when you have your calculators out, and I'll tell you exactly what buttons to push. But if I look here, I have a table, and you guys can always go to a table of values in your calculator too. And if I type in the x value that I want to see, so when x is 0, what is my y value? It tells me right here. So another thing we could do is look at the graph on our calculator. And the reason I like doing that is because the graph lets me know if I'm accurate or not, right? So I know that based upon my graph, the y-intercept should have been around in between 112 and 120, and it was. But if I type something wrong into my calculator, at least the graph kind of shows me if I'm on the right track or not. But I'll show you guys more how to use the calculator once we're in class together. But I do want to show you that that is an option. All right, I'm going to do one more with you, and then I'll let you try the last one on your own for homework. So what is the next one? Let's go into Microsoft Word. A tide problem. So yeah, the tides of the ocean, those are totally periodic, right? High tide, low tide. Let's figure out what's being asked of us here. Oh no, I think I actually skipped a question in that last one. Did I skip a? Find the first 3 times after they started timing that the temperature was 112. Well, that's nice because 112 is one of my key points here. So after they first started timing, so it's good that I worked backwards in my graph. So it happened at 5 minutes. It happened at 25 minutes. And it happened at 45 minutes. So that was important. We did have to work backwards on that one because it said find the first 3 times after they started timing. So that was important that we worked backwards there. Okay. Extreme fluctuations in tide. Okay, so we have a height and we have a time. The first low tide was 1.88 feet, and it occurred at 10:45 a.m. And the first high tide went all the way up to 13.25 feet, and that was at 4:30 a.m. So we want to sketch a graph here. The second high tide was recorded at 5 p.m. This is important, guys, is that I don't want you to like put time like 5 p.m. on your x-axis. I want you to just do time in hours. Okay, so let's kind of get a sketch on the side as to what's going on here. So at 4:30 a.m., so we're going to do time since midnight, okay? So this is important. So midnight would be t equals 0. So if I'm talking about 4:30 in the morning, 4:30 a.m. is t equals 4.5, right? 10:45 a.m., that's t equals 10.75, not 10.45, right? I'm 3/4 of the way through the hour. So that's something that your brain just has to be able to do. I'm not going to put 10.45 on my x-axis, okay? So 10:45 a.m. is t equals 10.75. And then the other time they gave us was 5 p.m. So 5 p.m., think about that. If we're talking about time since midnight, well, noon would be 12, right? So if I'm talking 5 p.m., that's 5 hours after noon, so that's t equals 17. I don't care about what time of day it is. I care about the hours since midnight. I'm measuring hours. I'm not measuring time of day. All right, so I'm going to get myself a sketch here. So it looks like they told me a high tide happened at 4:30, so that's 4.5, 13.25. And then I had another high tide happen at 5 p.m. So that's 17. 17, comma, the high tide is the same height, so 13.25. Okay. And it did also tell me a low, didn't it? So low tide was at 10:45 a.m., so that's 10.75. And the height was 1.88. So I do have enough information here to kind of get a sketch going. I have a midline, and I can easily find this. Alrighties. So if I want to find the middle height, I'll start with that. That's my y value. Oops, that eraser is too big. Let me erase on this side too. I've got to find the time that's in between and the height that's in between. So I just want to find the average of these things. So if I add these up and divide by 2, let's see here. I don't even really need to do all that. But I do, what I do need is the midline. Okay, so let's see. I'm going to avoid using too many decimals here. So I'm just going to find the midline, which is 7.565. I'm just going to put that here. I'm not even going to worry about these points in between unless there's like a follow-up problem that asks me about it. But I don't want you guys to get too confused with the decimals. So this is 13.25. Plus, I think this video is getting a little long. So, and my low tide was 1.88, and we just found the middle in between. So I added these up and divided by 2, and I got 7.565. Yeah, because I was a little bigger than 14. All right. So I'm only going to put the times on here that were given to me in the problem. And if I end up having to work backwards, I can and find the intervals. But I actually don't think this problem asks us to do that. So 10.75, and this one is 17. So let's see what happens here. So I know that there's some sort of in-betweener here. And if I have to find those, I will. I would just add them up and divide by 2. So this was a high tide, this was a low tide, and this was a high tide. All right, so that's my general sketch, and that's a full credit graph right there, okay? I've labeled enough that shows that I know what is going on. If it had asked for all of the intervals to be labeled, I would have done it, but I don't think this problem is going to get too crazy. Okay, so sketch a graph done. Write an equation modeling the times in terms of x and the number of hours since midnight. So all that means, guys, is that there's a horizontal shift, okay? And the horizontal shift is I have a positive cosine starting at 4.5. I have a negative cosine starting at 10.75. It's kind of whatever we want it to be. Okay, so we've got to find some values here before I can write this equation. So I have my amplitude, so that's the distance between 7.565 and 13.25. So I'm going to subtract those two, right? 13.25 minus 7.565. And I'm going to get my amplitude. And that's 5.685. All right. And now I have to find my b value. So 2 pi over the period is equal to b. So the period is the amount of time it takes for one full wave. So that's what, 12.5 hours, right? 17 minus 4.5. That's the amount of time it takes for one full wave. Because remember, time is your x. So I want to do 2 pi over 12.5. And I'm never, ever going to leave a decimal in a fraction. So that's going to be 4 pi over 25 is my b value. All I did was multiply the top and bottom by 2, right? So 2 over 2 is like multiplying by 1, so that's 4 pi over 25. Okay. And I know my horizontal shift is 4.5, and I know my midline, I found that already, is 7.565. Okay, so I can write this equation. So y equals 7.565. I'm going to do a positive cosine because that showed up first. Plus my amplitude is 5.685. So these silly decimals are a little annoying, but we can work with it. Positive cosine of 4 pi over 25. Now notice I'm using like an extra set of parentheses here. That's really just for calculator purposes. If I kind of read ahead and I looked at the next question. So I knew I was going to need that extra set of parentheses when I put this into my calculator. And I put my horizontal shift in. To the right, 4.5 hours. So that's a perfect equation, full credit. How high was the tide at 8 a.m.? All right, I just need to plug in 8. X is the time, right? So if I plug in 8 a.m., and if it had said 8 p.m., that would have been 20 I was plugging in, right? Because noon is 12. but it's asking for 8 a.m. So I'm literally going to type into my calculator, guys. So I'm not even, all I'm going to type into my calculator is 7.565. So you should be doing this too. Put this into your calculator. Plus 5.685 cosine. And as long as you have this extra set of parentheses in here, you can just type in exactly what this says. So 8 minus 4.5. Okay, so if you are taking the cosine of this entire value, you can type it in just like that, and it's going to tell you the height at 8 a.m. So how high was the tide at 8 a.m.? I'm getting 6.5 feet. And let's see, 8 a.m. Yeah, I mean, it would be right about here, don't you think? A little after that midway point. So that's so cool. It kind of works out perfectly with our graph. Okay, there is one more for you guys to try on your own. I think it's the height or the distance a pebble is stuck in a wheel. You guys try that one. I have no idea how long this video is at this point, but I'll let you guys try that one. And this was just an intro, so just remember, we have a ton more of these to do. So this is not going to be on your quiz on Friday or Monday, depending upon when you have it. We need to do a lot more of these before we feel comfortable with them. So hopefully it was a nice little intro and we're sort of comfortable with it, but we just kind of feel like we need a little more practice. But that's all for today. I will talk to you guys later.